In this video, we will learn about atomic number and mass number and see how they apply to elements, isotopes, atoms, and ions. Ever since we discovered that atoms existed, it's been important to know what they were made of. We now know that every atom or simple ion has a nucleus, and in that nucleus are protons, which have a positive charge, and neutrons, which are neutral. Collectively, protons and neutrons are known as nucleons because they are particles commonly found inside a nucleus. Around the nucleus, we find electrons in the electron cloud. Protons and neutrons have roughly the same mass. However, electrons have much less mass, so most of the mass of an atom or simple ion will be because of the nucleus. So this raises a question. How do we best describe nuclei and compare one to another? If you count up the protons in a nucleus, you'll get that nucleus's atomic number. For instance, a nucleus of carbon contains 1, 2, 3, 4, 5, 6 protons. So this nucleus and all nuclei of carbon have an atomic number of 6. However, the atomic number can mean slightly different things depending on what you're referring to. At its simplest, atomic number of a nucleus is simply the number of protons in that nucleus. You might use this in a phrase like this: a carbon nucleus has an atomic number of 6. But what if we're not looking directly at the nucleus, instead we're looking at an atom or an ion? If we're talking about the atomic number of an atom or a simple ion, then the atomic number is the number of protons in the nucleus of that atom or ion. Therefore, for a carbon atom, we'd say a carbon atom has an atomic number of 6. Lastly, how do we talk about atomic number when we're dealing with an isotope or an element? The atomic number of an element or isotope is simply the number of protons in any nucleus of any atom or ion of that element or isotope. So you might say that the element carbon has an atomic number of 6. The atomic number is unique to each element. In some ways, giving the atomic number of an element is the same as giving the name of the element. So in practice, if you know the element, you therefore know the atomic number because you can look it up on the periodic table, and therefore you know the number of protons in the nuclei. For example, if you know that you're dealing with the element carbon, or you know that you've got an atomic number of 6, or there are 6 protons in the nuclei, you can figure out the other parts of the circle. Now, so far, we've understood different nuclei based on the number of protons they contain, but they also contain neutrons. How do we account for that? For almost every nucleus, protons are only a part of the story. About half of the mass of a carbon atom is because of the neutrons. The mass of our carbon atom is about the mass of 6 protons plus the mass of 6 neutrons. The electrons don't have enough mass for us to worry about at the moment. If you add up the number of protons and the number of neutrons in a nucleus, you'll get what's called the mass number. This particular atom has 6 protons and 6 neutrons, so it has a mass number of 12. There is something a little confusing about the mass number. It is not a mass, it's just a number, like the number of cats and dogs at your house. So that begs the question, why is it called mass number at all? The mass number is called mass number because it's very close to the relative atomic mass for that atom or ion. This is usually good enough for a rough calculation. Uniquely, for this type of carbon atom, the mass number and the relative atomic mass are identical, and the average atomic mass for this type of carbon atom is 12 unified atomic mass units. But let's see what happens when we have one more neutron in our carbon atom. The first thing we notice on our magic scales is that the mass of the atom has increased by about 1 unified atomic mass unit. This is roughly the mass of 6 protons plus the mass of 7 neutrons. But we still have an atom of carbon because there are 6 protons. But we have a different mass number this time. 6 plus 7 is equal to 13. So the relative atomic mass of this particular atom is about 13, and the average atomic mass is about 13 unified atomic mass units. These variants of carbon are what we call carbon isotopes. This is why the mass number is useful. It allows us to distinguish between isotopes of the same element. We use the mass number in the name of the isotope because it's a nice round number that uniquely identifies the isotope. Now let's have a look at the definition of mass number on each level. The mass number of a nucleus is simply the number of protons plus the number of neutrons in that nucleus. For example, a carbon-12 nucleus has a mass number of 12. So what about atoms and simple ions? Mass number of an atom or ion is the number of protons plus the number of neutrons in the nucleus of that atom or ion. For example, a carbon-12 atom has a mass number of 12. Lastly, we need to think about mass number in the context of isotopes and elements. The mass number of an isotope is the number of protons and neutrons found in every nucleus of atoms or ions of that isotope. For example, carbon-12, the isotope of carbon, has a mass number of 12. You need to be careful when you use the term mass number and element because mass numbers apply to isotopes of an element and not necessarily the element itself. Elements can have more than one isotope and therefore there isn't a distinct mass number for those elements. Now let's look at the most common scenario where you'll find atomic number. The periodic table. You can use the periodic table to find the atomic number of any element. You can also use it to make a good guess at the mass number of the most common isotope. We can pick out carbon on the periodic table. Inside the cell for carbon, you might see two numbers. The smaller of these is the atomic number. The bigger number is the average atomic mass, without the units of unified atomic mass units. The average atomic mass is calculated based on the abundance of the isotopes on Earth. It just so happens that most of the carbon on Earth is carbon-12. So it works out that the average atomic mass for carbon is quite close to the mass of the most abundant isotope. So we could have actually worked in reverse and looked at the average atomic mass and predicted that the most common isotope for carbon would be carbon-12. However, that doesn't work for every element. For instance, bromine is an element that can be found in group 17 of the periodic table, and its average atomic mass is 79.904 unified atomic mass units. So you might think that the most abundant isotope of bromine on Earth is bromine 80, which would have 35 protons and 45 neutrons per nucleus. In actual fact, of the bromine nuclei on Earth, about 50% are bromine 79 and about 50% are bromine 81. And it just so happens that the average atomic mass averages out at about 80 unified atomic mass units. So just bear in mind that finding the mass number of the most common isotope using the average atomic mass doesn't always work. The last thing we're going to look at is how to represent atoms, ions, isotopes and elements using nuclide notation. With nuclide notation, we start with the element symbol. We put the mass number, if there is one, to the top left, and if you want to, you can put the atomic number to the bottom left. So let's imagine we start off with an element. In this example, our element is carbon. We look up carbon on the periodic table, and we see that the element symbol involved is C. That starts off the nuclide notation for our element. If you wanted to, you could include the atomic number of the element, 6, in the bottom left. However, this isn't necessary because you could use the letter C to look up the atomic number on the periodic table. But what if you had a particular isotope? Let's imagine we've got carbon-12. We can look up the element carbon on the periodic table and get the symbol and the atomic number for that isotope. And then we can take the mass number of that isotope and put it in the top left to uniquely identify it. If you wanted to have the symbol for an atom of the element, you might just use the element symbol on its own or the element symbol with the atomic number. If you wanted to be really clear, you could add the number 1 before the symbol, meaning 1 carbon atom. And you could do the same thing with an atom of a specific isotope with or without the atomic number. For the equivalent ion, all you need to do is add charge in the usual place, in the top right. After all that, I think it's time for some practice. Neon has an atomic number of 10. How many protons are there in an atom of neon? Neon is the name of an element to be found on the periodic table of elements. It's in group 18, otherwise known as group 8, and period 2. An atom is a nucleus surrounded by an electron cloud. Inside the nucleus, we can find protons and neutrons, so when the question asks how many protons are there in an atom of neon, we're looking inside the nucleus. The question also tells us that neon, the element, has an atomic number of 10. We can see that in its cell on the periodic table. The other number in the box, 20.180, is the atomic mass of neon. We don't need that for this question. The atomic number of an element is the number of protons we can find in every atom or simple ion of that element. So all neon atoms or ions contain 10 protons in their nuclei. And we can even flip that around and say all atoms or ions with 10 protons in their nuclei are neon. Therefore, we can say with confidence that the number of protons in an atom of neon is 10. Our next question looks at using both mass number and atomic number. An atom of calcium has a mass number of 42 and an atomic number of 20. How many neutrons are there in its nucleus? An atom consists of a nucleus surrounded by an electron cloud. In the nucleus, we can find protons and neutrons, and electrons occupy the electron cloud. We won't need it for this question, but it's important to remember that atoms are neutral, so they have the same number of positive protons and negative electrons. The next thing we need to ask ourselves is, what do we mean by an atom of calcium? Calcium is the name of an element, and we can find information about calcium on the periodic table of elements. The first thing you might notice is that the number in the box for calcium is the same as the atomic number of the atom of calcium. The atomic number is simply the number of protons in an atom or ion of a particular element. So the first thing we realize is that we have 20 protons in our atom of calcium, and while it doesn't make a difference in this question, we also have 20 electrons. The other piece of information in the question is that this atom has a mass number of 42. The mass number is the number of protons and neutrons in the atom or ion. So this tells us that if we take 20 and add the number of neutrons, we'll get 42. All this sets us up nicely to answer the question, how many neutrons are there in the nucleus of the atom of calcium? The number of neutrons must be 42 minus the number of protons, which is 20. Therefore, the number of neutrons in an atom of calcium with a mass number of 42 is 22. And here, with the key points, we have atomic number, the number of protons in the nucleus of an atom or ion of an element. The mass number is the number of protons and neutrons in the nucleus of an atom or ion of an isotope of an element. Elements are identified by atomic number, and isotopes are identified by atomic number and mass number.